So today, what we're going to do is we're going to talk about functions. Okay, we're going to talk about functions. So if you want to go ahead and look at the key concept on functions. Okay. So.
Yeah, she is texting.
Whoa.
So anyway. So now, what we're going to do is if you look at this, it says a function f from set A to set B is a relation that assigns to each element in set A exactly one element y in set B. So basically what that's saying is here you've got your set A. You've got your numbers 1, 2, 3, and 4. If it is a function, there will be exactly one y value for the number 1. There will be exactly one y value for the number 2. There will be exactly one y value for the number 3 and exactly one y value for the number 4. That is what a function is. And so if you look at this, this is in fact a function. We call set A our domain. Remember, our domain is the set of x's. We call set B the range. The range is our set of y's. And so in looking at that, the domain is 1, 2, 3, and 4. It's the set of numbers. Notice the little squiggles, the notation there. B is the range, and if you look at there, we don't use the number 7. So as a result, we don't write 7 in the range. So the range is just 6, 8, and 9. Now one of the nice things about functions is that if worse comes to worse, there's an easy way to determine if you've got a function. And that's what's called the vertical line test. The vertical line test states if you were to take a vertical line and you were to move that vertical line over the graph of anything, you can determine if it is a function if it only touches at most one point. So if I drag this line across, I notice that at any given time, it only touches one point. Therefore, this would be a function. Now, if I did something like this, is this going to be a function? No, because at this given point in time, I touch 2 points. So, if all else fails, plot the points if you're confused, and do the vertical line test. That's the easy way. Let's go ahead and look at what we have here. It says determine whether the relation represents y as a function of x. The input value x is the height of a student in inches, and the output value y is the number of books that a student owns. So x is the height of a student in inches. Y is the number of books that a student owns. So how tall are you? 5'4". Anybody else 5'4" in here?
6.
Okay, so 5'4" would actually be 64 inches, right? How many books do you have at home? I don't know, let's just approximate 30.
Okay.
How many books do you got at home? 40?
Yeah.
Okay. Is that going to be a function? No. Why not? You have two 64s that go up to 30 and the 40. So when you think about this, if you were going to go ahead and draw out your numbers here, your height in inches as your inputs, and then you put the number of books they own over here, your 64 here would have 2 lines going here, and that is why it is not a function. Let's look at another one. Determine whether the table represents y as a function of x. Is that going to be a function? No. No, once again, because you have 2 values for 1. You have 2 values for 4. Let's look at this next one. Is that a function of x? Why? Vertical line test, exactly right. Do your vertical line. That's all you have to do on this one. Okay, you got your vertical line here. Run your vertical line over that. That is a function of x. Okay? That only touches at most 1 point. Now, one thing I want you to pay special note to is that this graph is something of this equation, y equals x squared. We learned about those briefly, real quick before you took the NISA. Y equals x squared is a parabola. Do we remember what y equals negative x squared looks like? It's the same thing except for it goes down. Okay? So, x squared, y equals x squared goes up, y equals negative x squared goes down. This one is a little different because what does this one say? X equals y squared. So this is different than the problem before. Can somebody guess what this is going to look like? It's going to go sideways. So whenever you have x equals y squared, file this away. X equals y squared will be a sideways one. Y equals x squared is up and down. Will this be a function? This is not a function because it does not pass the vertical line test. So not a function. Is this one going to be a function? Why? Here we go. This is what we call manipulating things around to try and get something that we know. Y equals negative 12x squared plus 8. By moving that x squared to the right, we have now made this y equals x squared. We know that y equals x squared is either an up or down parabola, and as a result, it will be a function. Okay, this one should look real familiar. If f of x equals x squared minus 2x minus 8, find the function value for f of 3. What do? Plug in 3. Perfect. I'm going to plug in 3 here for x. And then all I'm going to do is find out what number that comes out to be. Okay? So what do you got? 9 minus 8. So your answer is negative 5. Okay? That's just basic function notation. You're just plugging values in. However, if I have something like this, how would I do that?
Every x you put into a minus 1.
Yep, every x I'm going to put a 2a minus 1. Now one of the important things is to remember that that's a quantity 2a minus 1. So I'm going to go ahead and plug that in. Wherever I see an x, I plugged in 2a minus 1. Now how do I simplify 2a minus 1 quantity squared? FOIL, good. We don't just distribute the squared. Remember, what we need to do is go ahead and write that as 2 quantities. Now, in order to FOIL that, remember, that I use first outer, inner, and then last. So my first terms will give me 4a squared. My outer term will give me negative 2a. Inner term will give me negative 2a. And my last term will give me positive 1. Now what I need to do is distribute that negative 2 here. If I distribute negative 2 to 2a, I get negative 4a plus 2 minus 8. Our final step here will be to go ahead and add like terms together. So my answer will be 4a squared. So that's all by itself. I've got a negative 2a, negative 2a, negative 4a, which is negative 8a. 1, 2, negative 8, negative 5, and there you go. So that is your answer. So, questions? Think you can handle that? All right, so now this is something you probably want to write down if I were you. We're going to talk about something known as domain. And right now this probably isn't going to make complete sense. And that's okay. I need you just to hold on. Hopefully by the end of the chapter, all the pieces will come together and you'll be able to see how everything works. So if these next few problems don't make complete sense, that's okay. We'll hopefully have that taken care of by the time we get to the end of the chapter. So first of all, we're going to talk about domain. Domain, if you remember, is our set of x values. That's what the domain is. Now, we're going to find the domain of certain functions, domain of square roots, domains of fractions. And so here, if I want to find the domain of a square root, I'm going to take whatever is inside the square root, and I'm going to set it equal to 0, and then I'm going to solve for the variable. To find the domain of a fraction, I'm going to take whatever's in the denominator, set it equal to 0, and then solve for the variable. So those are 2 things I'm going to do. And like I said, get through it today, and gradually we'll build on this. And so hopefully by the end of the chapter we'll have made some sense from this. Okay, so we're gonna go ahead and look at an example. All right? Our example is gonna be as follows. State the domain of the function g of x equals square root of 4x minus 1. So if you remember what was just on the previous slide, it said take whatever's inside the square root and do what?
Equal to 0.
Set it equal to 0. So I'm going to take 4x minus 1, and I'm going to set that equal to 0. The next step was to solve for the variable, so I'm going to solve for x. So to solve for x, I'm going to first of all add 1 to both sides, so I get 4x to equal 1. Next step is to do what? Divide by 4. So really I get x to equal 1/4. Now what that 1/4 does is that 1/4 is actually the boundary point. Because if I have a number less than 1/4, what type of number am I going to get in the square root? I'm going to get a negative. If I have a number bigger than 1/4, what's going to be inside the square root? A positive. So this number you're finding is the boundary between negative numbers and positive numbers, because you've learned that 0 is the boundary from negative to positive. And so when I think about that, can I ever take the square root of a negative number? No. So really the only values I can use for x here would be the numbers 1/4 and bigger. So now I need to write that using that set notation we discussed on Thursday and Friday. Okay. Now I'm going to use the numbers 1/4 and anything bigger than 1/4. So anything and everything bigger than 1/4 I can symbolize by what? Okay, I could do greater than. Another thing I'm going to use is I'm going to use the infinity sign. And I'm going to actually use interval notation here because I think it'll be a little bit easier to understand. Do I include the 1/4, yes or no? Yeah, because I can take the square root of 0. Square root of 0 is 0. What do I do here with the infinity? Parentheses. If you chose to use set builder notation, you could have. It would have been x such that x is greater than or equal to 1/4, where x is an element of the reals. So you could have done that.
Reals or rationals?
The reals. The rationals are symbolized by Q. Remember, the reals means anything. So you could plug in root 3, and that would still work because that's bigger than 1/4. All right, we're going to look at another example, but I'm running out of time, so I'm going to go ahead and stop the video and start it up again.